All science begins with making observations and asking questions. These questions are often developed because people want to learn more about what they are observing. To find the answers to their questions, researchers use the scientific method, which is a structured technique used to test ideas and potential answers to scientific questions. Although the specific steps of the scientific method can vary by discipline, it is widely agreed upon that the fundamental elements of the scientific method include 5 steps. The scientific method starts with making observations, and then moves on to asking questions, formulating a hypothesis, conducting an experiment, and ends with interpreting results and making conclusions. Most scientific evaluations begin with someone making observations about something that is occurring in nature or the world around them. Observations are the first step in the scientific method, and they set the foundation that the preceding steps are based on. Once a scientist has made observations, they are often curious about what they have seen and want to learn more. At this point, scientists begin to ask questions about their observations, which is the second step in the scientific method. These questions can be very broad or specific depending on the topic being investigated. After a question has been asked, the next step in the scientific method can occur. The third step is to formulate a hypothesis. A hypothesis is a proposed explanation that aims to answer the question formulated, and the hypothesis must be testable through experimentation. The development of a hypothesis is a very important step in the scientific method because it is what the remaining steps are based on, and it will be returned to after more steps are completed. Once the hypothesis is created, scientists make predictions about what should happen if the hypothesis is found valid and therefore supported, and also what should happen if the hypothesis is not valid and is rejected. Conducting an experiment is the fourth step in the scientific method. An experiment is an activity designed to gather data that will be used to support or reject the hypothesis. An experiment involves multiple variables, which are specific factors that can be manipulated. Most experiments include an independent variable, which is the factor that the scientist alters, and a dependent variable, which is the factor that is being measured. When an experiment includes these aspects, it is referred to as a controlled experiment, because the scientist is in control of how each variable influences the experiment. This is an important part of the scientific method because by controlling the variables in the experiment, the scientist can determine which variable is causing the predicted result. Once the experiment has been conducted and all of the data has been collected, the next step in the scientific method is to interpret the results. The interpretation of the results includes analyzing the data and making conclusions about the hypothesis. First, the data is analyzed statistically to determine how the data from the experiment relates to the hypothesis and predictions proposed. After the analysis, conclusions are made by comparing the data with the hypothesis. If the data are found to not support the hypothesis, then the hypothesis is rejected, and the scientist must return to step 3 and formulate a new hypothesis. They will then conduct a new experiment and determine if their new data supports or refutes their new hypothesis. If the results from the initial experiment are found to support the first hypothesis, then the scientist often runs the experiment several more times to make sure the results are accurate. Once the scientist has confirmed that the results are accurate, they often publish their work in a scientific journal. Scientific journals are peer-reviewed, meaning that other scientists comment on and approve proposed manuscripts. The publication process is very important to the scientific method because it is when the information gathered from the entire process is made accessible to other scientists and to the public. The scientific method is used in many different fields, but let's examine how you can use it to solve an environmental issue. Imagine you are walking down the street and you notice that many of the yards in the neighborhood have yellow grass. This is your observation, and it is the first step in the scientific method. Next, you may ask yourself, why is the grass so yellow and not green anymore? And this is the second step of asking questions. You would then formulate a hypothesis as to why the grass is turning yellow. For this example, let's say that your hypothesis is that the grass is turning yellow due to the new pesticide being sprayed. In order to solve this problem, you would need to conduct an experiment. The experiment could involve growing some grass and exposing half to the pesticide. For this experiment, the independent variable is the amount of pesticide sprayed on the grass, because this is what you are altering. The dependent variable is the color of the grass, because this is the factor that you are measuring. If the exposed grass did not turn yellow, then you would have to return to the beginning and create a new hypothesis and experiment to determine the cause of the yellow grass. If you found that the grass you exposed to the pesticide did turn yellow, then your data supports your hypothesis. Now, let's review the steps of the scientific method and its importance to solving environmental problems. The scientific method begins with observations of a natural occurrence and then leads to the generation of questions based on the initial observations. Once a question has been determined, a hypothesis is developed that proposes a possible answer to the question. An experiment is then conducted to gather data that will be used to either support or reject the hypothesis. After all of the data has been collected, it must be interpreted, which includes statistically analyzing the data and making conclusions by comparing the results to the hypothesis. If the results do not support the hypothesis, a new hypothesis and experiment must be designed. If the results do support the hypothesis, the questions can be answered and the work can be published. By using the scientific method, it is possible to investigate environmental problems in a systematic and reputable manner. In the case of the yellow grass, the scientific method was a valuable tool in solving the environmental problem and bringing awareness to the cause of the issue.